All right, everyone. Hope you're all having a nice day. Rob here again from the DAE. We're doing another Python lesson this afternoon. This morning, we learned how to use lists and we made a randomly generated sandwich generator or randomly created sandwich generator, however you want to call it. But we used lists and we used some of the random function. We're going to take a look at the random function a little bit more this afternoon. Today, or this afternoon, I should say, we're going to be using Python to draw. We're going to be creating graphics with Python. And we are going to be using the Turtle library to do that. So Turtle's been around for a really long time. It's a library that allows you to do some really, really fun visual projects using Python. I really like it. We're going to be learning some basic functions with Turtle, and then we're going to be doing a fun project that involves some randomization and a ton of different variables and also some loops, which we haven't done yet. Now, again, just as a disclaimer, I am not a computer scientist. I'm not a programmer. I did not go to college for programming. I learned this as an adult to be able to communicate with parents and students and my instructors. And I really, really like it, and I have a lot of fun with it. But I am by no means an expert. So I'm probably going to write code in ways that could probably be written a little bit more efficiently. But that's not the point. My point is to show you all some really fun projects that we can create with Python. And it's just a nice way to get started with code. So with that being said, let's get started with this project. And I'm probably going to mess a lot of things up. In fact, I have the Turtle graphics documentation up because I frequently forget what functions to use and how to write them. So this, it's just right from python.org. I just Googled Turtle graphics Python or Turtle Python, and it brought this up, and it gives you all of the different functions that you can use. We're going to look into this in a little bit more detail as we start to explore the Turtle graphics library. But at any rate, I'm going to be referencing this a whole bunch because I know I'm going to forget things and I'm probably not going to write things the right way. With that being said, let's get going. So I have got idle opened. You can also use REPL for this, as I've mentioned in other videos. They have an online compiler for Python with Turtle, and it handles the graphics really, really well. I'm very, very impressed with REPL, but just for today, and as I've been doing consistently through this whole thing, I'm going to be using idle, and I have a new script open, and the first thing I'm going to do is save as. Now, I cannot save this as Turtle because there is a library called Turtle, and if I save this as Turtle, Python is going to be confused about which Turtle I want to use. So I'm going to call this Rob Turtle Test. And that way, the name of the file will not interfere with the Turtle library. I've run into so many issues where students get super frustrated because they write this great program with Turtle, and then they save it as Turtle, and they go to run it, and nothing works properly because we have conflicting names. So that will avoid that. So the very first thing we're going to do is import Turtle. And now our Turtle library is imported into Python, and we can use it. So before we do anything, I'm going to show you very simply with one line of code how to get some graphics on screen. And so the Turtle library uses a Turtle object. That Turtle object is called Turtle. We can also rename that and have multiple turtles to draw. I'm not going to do that. I'm just going to keep it the same. And I give it the command forward. And then I give that function a parameter of pixels. So I'm going to have my Turtle move forward 100 pixels. And when I run this, a box pops up and my little turtle draws a line of 100 pixels. So the turtle is just an arrow. We could actually change the turtle to be an actual turtle icon. I'm just going to keep it an arrow for simplicity's sake for now. But the point of this was to show you that after importing Turtle with one single line of code, I can start drawing. So before we do anything else, we're going to draw a square. So if we do turtle.forward to move forward, we can say turtle.left to turn to the left, or turtle.right to turn to the right. We're going to go to the left, and the units for this function are going to be in degrees. So we're going to turn 90 degrees, and if I run this, my turtle moves 100 pixels down that direction and then turns to the left 90 degrees. Well, we're going to draw a square. So that means I'll need to go forward again for 100 pixels. I'm going to turn to the left again. Turtle dot left 90 degrees. Turtle dot forward 100 pixels. So that would be one side, turn to the left. Two sides, turn to the left. Third side, and now we'll turn to the left. And our last side. And I'm sure I've put typos in here. I have the tendency to type truttle instead of turtle. You'll probably see that happen a few times, and that's okay. Python will give us the errors. So draw a cool little square, right? So all we need to do is give our turtle the directions to either go forward, left, forward, right, backward, all that kind of stuff, all those basic functions. Now, let's say I want to draw a square multiple times. Well, I could take this and I could copy and paste it. So I could basically draw a square, then move the turtle to a new location, and then draw another square using this by copying and pasting it, and then move the turtle to a new location and draw another square. But if drawing squares was going to be something that I was going to do regularly, it would be to my benefit to create my own function. Now, if you remember back from our quiz game lesson, I had explained a function which may or may not have been totally accurate, but in my understanding of it, a function is a keyword that contains a bunch of code that runs behind the scenes. And there are a whole bunch of functions that exist within Python, like print, right? Print is a function that exists within Python, and there's some code that runs in the background of print that makes it work. Well, what's really cool is we can make our own functions. So I can make a function called square, and every time I call the function square, it will draw a square. So to do that, we need to define the function. So we'll use the keyword def as in define, and I'm going to call this square, except I need to spell it correctly, with a capital S. It could be a lowercase s, that doesn't matter, right? Def square, and then we put a colon, and then we need to indent everything underneath our def line. Just like with an if-then statement, anything indented tells Python that it's contained within the line above it. So anything indented under def square is the code that's going to be included in the word square. So what we've effectively done is made our own function like print. This one does not take any parameters. All we need to do is tell Python that we want this function to run, and then it will run this code without us having to type it. So if I run this, nothing happens. That's weird. Well, it's not, because all we've done is define what the function square is, but we haven't actually used it yet. So to get it to draw a square, I need to call the function, and I need to spell it correctly. And then when I run it, it runs the code to draw the square. So now I can tell the turtle to go to a new location, turtle.go to. And we're going to put in some new coordinates. So let's go to 100 by 100. So what that is in our Cartesian plane, if let's say this window right here was our graphics window, every spot in this window has a coordinate of an x value and a y value, which x would be points along the horizontal plane, y would be points along the vertical plane. So I'm just going to arbitrarily say we're going to go to 100, 100, and then I'm going to draw another square. So all I need to do is call the square function, and if I run this, turtle goes to a new location, and I misspelled this, so it didn't work properly. Even though I said as I was typing it, I need to spell it properly. It's going to happen a lot. So now we go to a new location, and we draw another square. Right? Pretty cool. Let's go to another location. Turtle. And let's make it much more drastic. Let's go to like 500 by 500 and then draw another square. This will be more obvious. And I was about to misspell it again. Square. Okay, we got it. So now the turtle does one square, two squares, and then we go to another object that's way off, or another area that's way off screen, and draws another square. You can kind of see it peeking out in the corner over there. So defining your own functions, very, very nice way to save yourself from copying and pasting a lot of stuff. You just set your function up properly, and you can call it again and again and again to draw a square, okay? So let's delete this, and let's look at some of the different things that we can do in the Turtle library to customize our project a little bit. So I'm going to pull up the API here. So what's cool about this is it gives you all of the different functions you can use with Turtle, which will help you move it around, change the size, change the color, change the speed, all that kind of thing. So forward, backward, right, left, go to, bunch of different other functions. We can tell the turtle state, which means get its current position, and then we could change that position by a certain amount. The other thing is we have some drawing functions, which will allow us to put the pen down and pen up. The way I learned this when I was a little bit younger, when I was playing with micro worlds and doing some drawing using Turtle, was you think of the turtle as having a pen attached to its tail. And when it moves, it draws, but you can tell the turtle to lift up its tail, and that pulls the pen up. That was the way that I learned it. I always thought that was a pretty cool analogy. So let's play with the pen up and pen down functions. So we're going to draw a square and type it correctly. And then we are going to tell the turtle to take the pen up. And let's just double check that I've written that correctly. So it's just pen up, or I could even use PU or up. So I'm just going to use pen up just so we know what it is, a little easier to see. And then let's just check this out. If we go pen up, so turtle.penup does not take any parameters, okay? And then we're going to tell the turtle to go to, let's go to 200 by 200. Again, I'm just arbitrarily guessing that. And then I need to put the turtle's pen back down, and that's going to be pen down. No parameters. And then finally, we draw a square. And up comes my window. Turtle draws a square, goes to another location, draws another square. And notice that we did not have a line connecting them. Earlier, when I had drawn the two squares and then the third square up here, the turtle drew a line as it was moving. By using the pen up and the pen down function, we can not have those extra lines drawn. So one of the projects that we do with our students all the time is we give them some challenges to try and draw certain shapes, like draw a house with windows and a door, which is fun and challenging. And we can use the pen up and pen down function to not have extra lines scribbling all over the place in our project, which is pretty cool. So now let's see what else we can do. So if we go back, we have pen up, pen down. We also have pen size. So let's play with pen size. So turtle.pen size, and we need width as a positive number, right? So that's the thickness of the line that it's drawn. So I think the maximum size is 10. So let's go ahead and set the pen size at the, actually, let's set the pen size here. So it draws one square at the normal size that we start with, and one with a larger line. Python is run from top to bottom. So the order that you write these lines obviously makes a huge difference. Like if I had the turtle.goto before pen up, it would move and still draw a line. It runs from top to bottom. So it would draw a square at its normal size, and then as we move down to draw the second square, it's going to increase the size to 10. So let's play with this function. So we draw one square of normal size, and then we draw a really thick square. Cool. That's pretty good. So let's look at some of the other functions we can use. We had pen size. We've also got some color. So we can use our pen color, okay? And our pen color can take different formats. We can use a color string, which means we can literally type in red, yellow, or we can actually use a hexadecimal code, like if you were doing web stuff. We can also use RGB values, right? So that would be set pen color, and then we put our 3 RGB values in there. So let's play with that. If we go back to our script. Come on now, doesn't want to close? This window does not want to close. All right, that's okay. We'll just run it again. It'll be fine. So let's change the pen size for the thicker square. So turtle.pen color. And let's just make sure I'm typing that correctly. We'll double check our API here. Yep, turtle.pen color. And then we're going to put in 3 values for the parameters. An R value, a G value, and a B value corresponding to red, blue, green. So let's make it green. So 0 for red, RG, 255 for green, and 0 for blue. Now, the reason why I knew it was 255 is that in the world of computers, RGB values go from 0 to 255. That's just the way it is. Those are the rules. And any combination of red, blue, and green from 0 to 255 for each of those values can create any color on screen. Any color that you see on your computer screen is just a combination of red, blue, and green. So we now should be creating a green square. So let's try and run this. We have our one square, and I have a problem. I didn't do something correctly. I may need to change the color mode. That may have been my issue. Let's take a quick look at the API because I did something wrong. Let's see. I need to set the color mode. So that's something that I hadn't done. I think by default, the pen color function uses a color string, but I need to tell it that I want color mode to be in RGB values, which is 255. So let's try that and see if that works. It may work, it may not. I told you I was going to make some errors with this because I don't always remember exactly what to do. So I'm just going to put color mode at the top because we're always going to do color mode in 255. I don't think that's correct. Hold on a second. What did I... Color mode, yeah, not camel case. It's with a lowercase m. Color mode, 255. Let's see if this works now. Nope. Color mode is not defined. Okay. So I did something wrong again. Let's just take a quick peek here because I'm definitely doing something wrong. Turtle.penColor. Well, before we do that, let's do it in a string and see if that works. So turtle.penColor, and we'll basically say blue, color string. And we'll see if that works. So normal. Okay, color string worked. So that works. But it doesn't seem to want to take my RGB values. So let's try this again and just make sure I didn't type anything incorrectly. Yep. So I got an error here. Bad color sequence. So it wants the string color. So somehow I have to define that I want the pen color to be in RGB. Let me just go back and double check. This is what always happens. It's fine. We can use our documentation to figure that out. It's no issue. So pen size, color, pen color. Let me just see. So color string, set pen color to the RGB color in the range 0. Color mode is either 1 or... Oh, so let's check our color mode function. So green.color mode, turtle.color mode. That may be what I was missing. So turtle.color mode, I'm going to set it to 255. So that may be, I probably needed the color mode, turtle.color mode. I didn't put the turtle dot part before. So now if I run this, this should work properly. Yep, there we go. We got our green color. So that was the issue. And you know, I knew I was going to make a mistake, but we can always figure it out using the documentation. But I hadn't told Python that I want this function to take RGB values. Without putting this line, Python expects you to just put the word blue, green, light green, you know, a color string. By changing the color mode to 255, that's telling Python that when I use the pen color function, it's going to take 3 values, R, G, B. So great, we figured that out. Awesome. Let's see what other functions we can play with. So let's go back here. I think I can change the speed. Let's play with turtle speed. So this turtle.speed, and the parameter is the speed as an integer, right? So parameters, speed, and integer in the range of 0 to 10, or a speed string. So the speed string I can put fast, fastest, normal, slow, slowest. The fastest apparently is 0, which is weird. But let's try that. Let's see what happens. So let's set the speed, turtle.speed, and let's set it to 0 and see if it runs any faster compared to 10. That was pretty fast. Let's put 10 in and see if it's slower than that. Wow. Okay, so 0 is the fastest. Okay, I didn't know that. I always thought 10 was the fastest, but that's helpful for me to check the documentation. So, okay, very good. So that's a pretty cool function. Let's see what else we can figure out here. There's obviously a lot in here. Oh, here's a good one. So one thing we can do is we can set the size of the canvas. Okay, that basically means the size of the screen that the turtle is drawing in. So let's see if we can find screen size, right? Turtle.screen size. So canvas width, canvas height, and background. So we can basically set the screen size and the background. And I assume the background is going to be a color string. Yep, color string or color tuple. That would be RGB value. I think I'm going to leave it white, so we're going to just leave the background out. But we're going to set our screen size using the canvas width and canvas height, which are basically our XY values. So let's do that as our first line. So we'll say turtle.screen size. I think that was correct. Turtle.screen size, yep. And then let's make it 1,000 by 1,000 in pixels. Now my screen is 1920 by 1080, I think, or some iteration of that. So this should fit pretty well. Okay, that's 1,000 by 1,000 apparently. What if we do 500 by 500? Let's see if that makes a difference. It could be I'm also doing something wrong. No, it's the same size, so I'm definitely doing something wrong. So let's see. Clear, reset screen, background color. Let's go back. Let's go back. I'm doing something wrong here. So screen size. So screen size, canvas width. Else resize the canvas the turtles are drawing on. Do not alter the drawing window. Huh, that's funny. Okay, no problem. We're going to figure this out as well in a minute. I don't want to waste too much time if I can't figure it out. But there is a way to change the size, and for whatever reason, it's not working for me now. I might be just using it incorrectly. That just might be my fault because I'm not remembering how to do this correctly. But I was pretty sure that the screen size function did it. Screen. Let's try screen.screen size. I don't know if that's going to work, but let's try it out. Screen.screen size. I don't know if we have a screen object created. Let's see if it's going to throw me an error. Yep, screen is not defined. Okay. Well, let's see what I'm doing wrong here. So, turtle.screen size. All right, I'm not doing that correctly. If anybody has an idea of how to do this correctly, throw a comment on because I'm clearly doing this wrong. So we're just going to stick with the default screen because I can't remember how to do this correctly. Like I said, I'm no expert, so no problem. Let's see. Okay, let's move on to doing something a little different. I'd like to do a fun project involving randomization. Now, I think we're going to need to set a whole bunch of variables. So let's talk a little bit about the project before I start going crazy. The screen size thing is going to drive me nuts. If we have time, I'm going to try to figure it out. But let's just, I'm going to let it slide for now. Let's see. I'm actually going to Google it really quickly because this is going to drive me crazy. Change screen size in Turtle. I know I'm doing something wrong. Screen size. Screen size. Let's see. Screen. Okay, so I guess I need to define a screen object first. That's the wrong thing. So I need screen equals screen, right? And then I can say screen. No. Screen dot screen size. equals 1,000 by 1,000. All right, I think I figured it out. Let's see if that works correctly. Screen is not defined. Screen equals screen. Huh. Still not working correctly. All right, I'm going to let this go because I don't want to waste any more time with it, but this is definitely driving me crazy. That's okay. We'll move on, and I'll figure it out, and then we'll do it correctly in a future video. So back to my project. So I'm going to delete all this, except import turtle and the turtle speed. That's it. Okay. So the other thing I want to do is import random. Okay. So what I want to do with this project is I want to have the turtle move around screen, drawing a circle of random diameter in a random place of a random color. So basically, it's going to be an autonomous project. The thing will just keep going and going until we stop it, and the turtle will draw a circle of random size and color in a random position on screen. So that means we're going to need a whole bunch of variables, okay? So one thing I'm going to need is I'm going to need a variable that we can make random that will control the X and Y position of the turtle. So I'm going to make a variable called xpos as an X position. And for now, I'm going to make it equal to 0. We're going to have Y pos. That's going to be equal to 0. This will make sense in a short while. We are going to have a diameter, a variable for the diameter, like the circle's diameter. So I think we're going to use, let's see. I'll do diameter. That's fine. Diameter. Good. Perfect. 0. We want to randomize color, and we're working in RGB because we have our color mode set to 255. So I need an R val, a RG val. Yep. I always get the B and the G mixed up. RGB. B val 0. Okay. So our X position and Y position of the turtle will be randomized. The diameter of the circle will be randomized, and the colors of the circle will be randomized. Now, these can actually go up at the top because we want that. So we are in color mode RGB. Our turtle is set to the fastest speed. The other thing that we need to do is I want the thickness of the line that the turtle draws to be randomized. So I'm going to say, I'm going to call it size val, as in the value that will have the size of the pen, and that's going to be equal to 0 right now. So all we've done is create these variables. We haven't, they just contain the number 0. We're going to change them in a minute. And what we're going to do is we want this to go on forever. So we need the actual code of this project to happen in a loop. Now, anybody that's used Scratch before, we have a forever block where things loop forever. We also have a repeat a certain number of times, like a repeat 10 times block. In Python, we don't have just a forever loop. The easiest way to do that is to do something called a while loop, right? And a while loop is kind of like an if-then. We had said, if, before we had said in the quiz game, we had said enter an answer, Y for yes or N for no. And we checked if the answer is Y, then print the correct answer. And if the answer is N, then print that you've gotten it wrong. So we're checking a condition. The condition was whether the answer is Y or N or something else. A while loop also has the same condition, right? You say while a condition is met. So I'm going to use the word true. While true. That means that as long as true is true, whatever's inside of this loop will loop over and over and over and over and over again until true is no longer equal to true. And in our project, we're not changing true to false ever. I could say when this loop runs 10 times, change true to false, and then it would break out of the loop. We're not doing that. We're going to say while true, while this is true, while it's on, while this is running, repeat this forever, okay? Then what we're going to do is we're going to reassign these variables to random numbers, okay? So I'm going to set the X position to a random integer. We talked about this earlier. In the random library, we have a function called randint, which randomly generates an integer. And our integer is going to be, let's just say, from negative 250 to 250. Okay, we probably will want to make that bigger because I couldn't figure out how to set the screen size, and I don't know how big it is. So we're going to do the same thing. Random.randint negative 255 to 250, or 250 to 250. Sorry about that. We need to set our diameter. So diameter will be equal to random.randint, and we'll make it from 1 to 100. We'll make it bigger, 1 to 200. And then our rval. So the rval, the gval, and the bval are going to deal with randomizing the color. So we're going to do a random.randint, and our values are going to be either 0 or 255, because we looked at before the max value that you can have in the red, green, or blue values for a color is 255. So we can either have no color or all the way full or anything in between. And we're going to do that the same for the gval and the bval. So random. Actually, I'm just going to copy and paste to save some time. All right, we'll do random, copy, paste. Right, so now in this loop, all of these things get randomized, and we actually also have to randomize the size val. So we know that our maximum size, this size val is going to be the thickness of the line that Turtle draws. So it's going to be from 1 to 10, right? So that way it could be a thin line or it could be a thick line or anything in between, okay? So now that we have set all of our variables to randomers. Oh, let's back up for 1 second. So I could have put the random.randint when we had defined the variables up here. The problem is that would get set one time and then the loop would start and those values would never be randomized again. Whereas in the loop, every time the loop starts, and the loop starts at the first line and runs downward, every time the loop starts, all of these numbers are reset to new random values, and then it's going to draw our shapes. Then once the loop is done, it's going to reset all those values to the random numbers between those ranges, and then draw the shape. Whereas if we were up here, it would set them randomly once, and then they would never change again. And that's not really what we're looking for here. So now that we have all of our sizes and everything randomized, we can actually start drawing. So what we're going to do is start with turtle.pen up. We're going to have the turtle pull the pen up, and then we're going to have the turtle go to a random location. Okay? So turtle.go-to. And I've created variables for its x and y position. So all I need to do is plug in here xpos and ypos, and Python will pull the values that are stored inside these variables, which are random numbers from negative 250 to 250, which is great. Then we're going to put the pen down, turtle.pen down. Then we're going to set the pen size, turtle.pen pen size, and it's our size val, right? That's going to control the size of the pen. Then we are going to set the color, so turtle.pen color, and we're going to put in rval, gval, and bval. So that way, when it runs this line, it's going to plug in our random numbers so that the color's randomized. And then finally, we can draw a circle. And we do have a circle, turtle.circle, I believe. And it will take a single value, which is a diameter. But let's just double check the documentation here to make sure I'm doing this correctly. Whoop, I went back too far. So let's just see if we can find circle. Yeah, we have a circle function, turtle.circle, and it takes the radius, not the diameter. So I'm glad I didn't make the diameter. This really should be radius, not diameter, but I'm just going to leave it the same now. You know what? Let's change it. Radius radius, and radius. All right, and so our radius is going to be anything from 1 to 200. Now, when I run this code, we're going to import the two libraries. We're going to set our color mode to 255, which allows turtle.penColor to use RGB values. We're going to set the speed as fast as it goes. Then we create a bunch of variables that we're not using yet. Then we go into our loop, and the loop will run forever and never break out of it because true is never not going to be true. When the loop runs, our X position and Y position now contain random numbers from negative 250 to 250. Our radius contains a random number. Our RGB values contain random numbers, and our size value contains a random number. Then the turtle's pen goes up. We go to a random position as defined by these random numbers. We put the pen down, set a random size, set a random color, and draw a circle. Assuming I haven't made any errors, and that's a pretty big assumption, this should be pretty cool. So let's see what happens. Window comes up. Hey, we start drawing circles. I didn't mess anything up. Now, you'll notice I'm only getting circles in a certain section of the screen because my screen size is larger than the top and low, the high and low boundaries of our random function. So I'm going to stop this really quickly, and I'm going to put in 500 to 500 for both the X and Y position values. So that way, let's see. That way we cover a little bit more of the screen. There we go. I wonder if I can make these lines any thicker. I feel like we could probably make these lines thicker. Also, one thing I'd like to do is I'm going to set the speed slower. And I think I'd like to make the size val. I don't know how large this can go. Let's check the documentation really quick and see what the largest value we can have for size is. I'm not entirely sure. So pen size. Our pen size is a positive number. Let's just see if it says anything about. I don't think so. I think let's just make it a larger. Let's put 25 in here and see what happens. I set the speed down too, so we can see when we run this the actual process of drawing the circles. So now it's as slow as it goes. I think we got some thicker lines in here now, which is good. So you can see that's what the program is doing when it's slowed down. But if I set this back to 0, I'm getting a bunch of errors too, but it seems to be running, so we don't care about that. Yeah, there we go. Now we have shapes of varying size. All right, very good. So let's let this run for a minute. Now, let's explore in the little time we have remaining here this while true piece. We had talked about this being similar to like a forever block in Scratch. I am going to change this to have this run 100 times and then stop. So I'm going to create another variable. I'm just going to say X, and X is going to equal true. Okay? So X is a variable that contains a Boolean, which is either true or false, on or off, 1 or 0. And we can use that to break a while loop. So what I'm going to do, actually, we're going to need another variable too. I think I'm thinking about this the wrong way. So we're going to have X equals true, and then we're going to have a variable that's called Y, and that's going to be equal to 0. So what we're going to do is we're going to change while true to while X is equal to true. So as long as the variable X is equal to true, this will work, okay? Then down here, actually there's a simpler way to do this, and I'm going to change it in a moment, but it's fine, it'll work. What I'm going to do down here is every time it runs this loop, I'm going to increase Y by 1. And remember when we had created our score in the quiz, we're using plus equals, which takes the current value of y, adds 1 to it, and saves it back to y. And then, you know what? I'm doing this way, way, way more complicated than it needs to be. Forget everything I just said. We're going to simplify this. All we're going to use is y, right? So I have a variable that says y equals 0, okay? Every time the loop runs, y is going to increase by 1. What I can do now is say while y is less than 100, run the loop. So I was way overcomplicating it and adding an extra variable that didn't need to be there. Remember, I am a hobbyist. I am not an expert. So what we're doing is saying while y is less than 100, run the loop. And every time that the loop runs, y is going to increase by 1. So when the loop runs once, y becomes 1. When it runs twice, y becomes 2. As soon as y, and I'm using less than, oh, that's what I wanted. As soon as y becomes greater than 100, it breaks the loop, and our program should stop. So let's see if this works properly. We start drawing. This should go through pretty quickly because I have it set to the highest speed. So we'll draw a few hundred circles, or actually 100 exactly. Well, I guess it would be 99, and then it stopped. Did you notice it stopped? That was because we reached our number 100. So we could do that as 500 or 800 or whatever. So that's how you would make a loop that's limited. So we can use the while true to run indefinitely, or we can create a variable that counts every time the loop runs, and that way we know how many times the loop will run by using while variable is less than a certain number. So I think that's going to wrap it up for today. This is a really fun project. I love doing these kind of randomized projects and having the computer basically create pretty cool looking artwork just using random numbers where we have no control over it. We're just letting randomization create the artwork. I enjoy that very much. I'm going to figure out that screen size thing because that was driving me crazy and I know I'm doing something wrong. Again, if you know what to do, just throw a comment. I'll look it up and then in the next video, I'll put the resolution as first thing we work on. But at any rate, outside of that, we covered using the Turtle library and the functions within Turtle library. We took a look at the documentation for the Turtle library, which is quite comprehensive. We looked at drawing shapes. We looked at defining our own functions briefly. That's something I think we'll maybe get into in our next lesson. We might make a calculator where each math operator is a different function, and depending on what you want to do, it will call different functions to do different, addition, subtraction, division, multiplication, so on and so forth. So that's really, really important. We also we looked at the while loop today. We looked at using random.randint. And we built this pretty cool project. So that's going to wrap it up. Thanks so much for tuning in. I definitely hope you'll tune in next time. And keep in mind that we are going to be offering a whole bunch of great online classes if you'd like to dive into Python in a little bit more detail. These are going to be interactive online classes where the instructor and students can share each other's screens and look at each other's work. And it will be basically like a class at the Digital Arts Experience, but totally online. So definitely stay tuned for the online classes. In addition to that, we're going to be offering private lessons online. So if you're interested in a topic or you're interested in diving really deep into Python or Java or Unity or whatever that might be, definitely get in touch. Give us a call, 914-644-8100, or shoot an email to info@thedae.com. We have some really, really talented instructors here that can take you through any kinds of projects that you might be interested in. But I think that's going to wrap it up for today. Thanks so much for tuning in, and I look forward to seeing you next time. Have a great day.